Okay, well, welcome to an exciting network programming class. My name's Professor Lyon, and I'll be recording our lectures for our distance learning section, and I'll be uploading them to our website. And what I'd like to do is just kind of go through a couple of preliminaries. First, in this class, I'd like to make use of Java programming for the network programming portion of this course. And so what we'll do is we'll cover what I will call basic networking, networking concepts, but we're also going to cover some detailed network programming. In order to gain access to all of the courseware available for this course, I'm going to ask that people use my personal website. So I've got my courseware loaded up, and there's a special Computer Networks link. And in the Computer Networks link, I'm starting up fresh with nothing in the link and nothing in the page, but I'll continue to add stuff to the page. So when you want to go to the course web page on my own personal website, it's at www.docjava.com. And then what you can do is you can monitor the page for changes. So as I change things on this site, you'll be able to get an update. So why don't you give me an email address and I'll show you how this works. Kyle, you want to tell me your address?
Yeah, my small one or
whichever. You can use your preferred address. Okay, so then when you do something like this and click OK, notice it fills in the URL, puts in your email address, and then when you hit Next, you can tell it if you want it to look at once a day, once a week, once a month, or use an RSS feed. I never use the RSS feed. I just want a an alert, and the subject that comes in is going to be something like the name of the course, Computer Networks. And you can submit the page to the public directory if you want. You don't have to look for sizable changes, and just hit Create. And then as I add links to this, what is he asking me for? Oh, a confirmation code. I guess you have to put in the confirmation code when you get your email. Otherwise, it looks like I'm trying to spam you. So this will be one of those things that may or may not work. Usually I'm logged in. I don't get those confirmation codes. Another one you can do is the Yahoo group. You can put your email address in there, and then when I send an email out to the Yahoo group, you'll get it. And that email address does not have to be a school address. And when you hit Join Yahoo Groups Now, you can put in your contact information and go through the whole process. Let's see, what else? I've got another course which I'm running in tandem called Biomedical Imaging. And in the Biomedical Imaging course, I've got a series of lectures available. And these are screencasts, and they'll give you some interesting intros. Let's see. Oh, he wants me to log in? Really? How about that? So there is a whole series of different interesting and wonderful screencasts that are here. This one is going to tell you how to build course code on a Mac. And Kyle, you use that one. I made that for you. He was getting stuck on how to do a build using the IDE, the Integrated Development Environment. This one sort of shows you how to download and install IntelliJ, which is the IDE that I use. And if you want to use IntelliJ, I will send you.
Fans, I just wanted to give you a brief
This will do full screen, I think.
downloading the new version of
Oh.
IntelliJ. You don't have to buy it.
How does one do full screen? I guess I don't have the resolution for that here.
If you're on Windows, you want to get the Ultimate Edition.
I think Escape will get out of it.
Download Ultimate.
Here, I've got to shut myself up. So then here's a two-part series on how to build the course code using Windows 7. So you can watch that as well. And when you're done with these sorts of things, you'll be able to do a proper build on your own. And that's one of the things that I would like to do kind of as a Blackboard assignment. So what I'll do toward the end of the course is I'll create a homework assignment, and you guys can submit the problems that you had during the build so that we can try and address them during the coming days. So not everyone will be able to do the build appropriately right away, and that's understandable. Sometimes it's a lot of code. It's not a particularly easy build. In fact, it's probably one of the more complex builds that you're going to encounter. When you're done, you should be able to run IntelliJ. Although for some reason I think maybe it should already be running. Yeah, I guess it isn't. I must have quit out of it. And once the IDE is up and running, you'll have access to the full course code. Let me think about this a minute. I believe there are 4,700 separate files in this project. So it's kind of a big project. There's also, I would say, a large number of classes, many more classes than there are files. I don't know if anyone here has worked with projects that are larger. Most students don't work with large projects. Has anybody got a favorite IDE that they like to use, a favorite integrated development environment? Not IntelliJ? Like Eclipse? You got a couple of Eclipse users? Yeah? Most everyone but me? Kyle, how about you? What do you like? You have? Yeah. Which do you prefer?
I haven't really used anything else enough to...
Oh, okay. Have you used IntelliJ any?
Only to build.
Only recently in a build for the biomedical imaging course. Yeah, I liked IntelliJ so much that I kind of got stuck on it. And I got to say that it's my preference, but you know what? Use whatever you prefer. I really don't care. I'm not religious about it. The thing I liked about IntelliJ, not to kind of be the salesman, is that it had very good refactoring. But then I found Eclipse was catching up. So now maybe Eclipse is as good, but I'm not sure. In any case, when you're done and you get a clean compile, you should be able to get things like this address book to work. And so this is one of those little program projects that I have on the side, which just lets me do things like automatically dial the phone. And this address book, yes, sir?
Did you look at the API that Yahoo thing?
Oh, the API from Yahoo was discontinued by Melissa Meyer because she wanted the company to focus on what she thought was important, and therefore all of the developers could go take a hike. This goes to the question of whether the reputation for a company is a coin which can be easily minted. And the answer is yes. If you're trying to mint a coin that shows you have a very poor reputation, it's very easy to do. She basically took what I thought was the goodwill of the developers and said it is of no worth. So anytime she accounted for goodwill on the balance sheet, she should have taken into account all the bad will that she created by pulling the rug out from under the developers. I'll tell you the story. Yahoo came to the cloud community very early. Yahoo provided an inordinate number of libraries that you could depend upon in order to gain services. Once the services were embedded in the community, people wrote about them, they thought they were wonderful, and lots of people started to use them, which is fine. And then they get a new CEO, and it's a new day, and they decide to take all the cloud services and discontinue them. So now everyone who's invested substantial development effort into these services has essentially become very disillusioned with the company. And as a result, they're sent the message that their time is useless or worthless, and therefore they don't count. And what this basically means to individuals who write about Yahoo is they write many interesting and wonderful disparaging remarks, in an effort to express their disappointment. So that's I'm a victim of this as well. So I'm quite biased. So I don't wish to say too many disparaging things, other than they set this thing up to become dependent upon, and then they revealed themselves to be undependable. I think that's the best way to put it. Yeah. I relied upon their API with a reasonable expectation that they would continue to support it, and then they decided no longer would this be the case.
Yeah, strange coming from a big company too.
Well, it didn't cost them very much to just leave it alone and not do anything, but instead they actively destroyed all the, I used to have a data mining menu item in here which was for building points of interest for TomTom. I removed it. I removed it because the API from Yahoo had been removed. So what it used to do is it used to give me, this is a basic network programming thing. It used to give me access to all of the, let's say, antique dealers, or all the lawyers, or all the whatever you're looking for within a certain range. And then it would give you a point of interest database that you could transfer over to your GPS system. And then if you're traveling around and you're looking for, let's say, a Dunkin' Donuts, it would say, oh, there's a Dunkin' Donuts right on the way, and here it is. So you could make custom points of interest for your GPS. I would consider that to be a very useful and API, and I think, if they want to charge for it, fine. But instead, they just actively disabled it. And unfortunately, there's nothing you can do about it as a mere mortal. Let me see if there's anything else left in my data mining system. Yeah. So this is an act of data mining as well. Here I'm reading in stock ticker symbols. And why I got a socket exception, I don't know. That's kind of the kind of bug that would really bother me if I was in the middle of a development cycle. But you can see what's happened here is I've gotten a price from Apple. This is also from the Yahoo API, which may or may not have been disabled or modified in some way. So in theory, if I go in and look for AAPL, it says 5:52 and 37. So this is a 20-minute delay, I think. Let's see if the high and low. He says the open was 550.91, and I have 550.88. And he says the low is 547.81, and I have 547.81. So that's correct. So there's certain disparity here. He says the time is 2:06, but of course it's 2:23 by my watch, so this is definitely delayed, this quote. But that's all right. The fact is you can go out, you can get these quotes, even if they are delayed. You can get historical quotes. You can do things that allow you as a network programmer to gain access to a whole bunch of series of services. And so that's, compelling and interesting. And the question of what kinds of services you can provide is really open. Let me see if I can quit out of this. There we go. So I thought that was interesting, that you could, create something as simple as an address book program use it to do stuff like dial the phone, do data mining. In one case, the data mining address book was going out to the yellow pages and then populating itself with all of the people in a certain category or certain area. That's another example of network programming. And other examples of network programming that are in here, network computation. Right? So network computation, if you look around in the room here today, you see a whole series of computers. Well, these computers are basically idle. Right? And idle computers depreciate rapidly, they suck down power, they throw off heat, and they serve no useful societal purpose. But if you can have them volunteer themselves into a grid of computing, then what you're doing is you're transforming all the computers into a supercomputer. So that kind of network programming is what you call parallel computing. And that's true parallel computing. And so we'll talk about the difference between true parallel computing and non-true or sort of simulated parallel computing. You see that often when you have a multitasking operating system. You don't have true concurrency. It simulates concurrency with what's called a round-robin scheduler. So that's kind of an interesting idea, right? Because if you have all these CPUs and you have I'll call it, parallelizable algorithm, you should be able to accelerate the rate at which that algorithm is executed. Presumably with zero overhead in that parallelism, you would see a tenfold increase if you added 10 computers. But if there's overhead, it'll be somewhat less than that. That would be optimistic. Let's see what else we can see about this. Here's a data mining program that I created that does data mining with Kickstarter. Kickstarter is a crowdfunding platform. And what you'd like to know is, what are the chances of being able to fund some project? And so what this does is it goes out to all the different Kickstarter projects and it looks to see how much money they asked for versus how much money they raised within certain categories. And so you can say, well, gee, if it's an iPhone related project, it usually raises about as much money as it asks for. But if it's an Arduino related project, it raises 3 times more money than they ask for. So there are certain kinds of projects which are inherently more successful than others. I don't know if you guys are familiar with Kickstarter and crowdfunding. Is that something you've heard of? Yeah. So I had a little crowdfunding project which was an outcome of this data mining activity, and it was one of those things where I said, that makes perfect sense. Not everything is going to be as successful as everything else. Other things you can do, of course, sending and receiving mail, being able to do multicasting. We'll talk a little bit about that in the course. Being able to do distributed file systems, being able to do relational database management system computations. That what happens with a relational database management system backend is you can have access to an enormous amount of data. And when we think about the architecture of server-side computing, that usually resolves itself around this idea that you will have 3 tiers, right? A tier is like a platform. So one tier might be the client, that's your browser, and another tier might be sort of like this web server, which you can sort of see. And then there is this back end, right? And the back end can be divided into a couple of tiers. One tier might be an application server, and another tier could be the relational database management system backend. So you've got the client, the web server, some business logic, and then this huge database. And it makes sense to keep that database in the backend so it can be searched efficiently, because what will happen is it'll be something like Amazon. And Amazon will be looking for a database that's huge so that they can conduct transactions. I have a friend, he writes textbooks for a living. I've been corresponding with him. It's a $142 textbook. He gets a 5% royalty from McGraw-Hill Higher Education. Well, it turns out Amazon gives a 70% royalty, which is unheard of in the industry. Well, McGraw-Hill Higher Education lost $62 million last year. That same year, Amazon sold 465,000 books, half a billion books, a staggering number of books. Apollo Group, which owns McGraw-Hill, is looking to sell the McGraw-Hill Higher Education division because who wants to own a business unit that loses money every year? Nobody, right? And they're like the dead man walking. So Amazon has essentially turned the entire industry on its head. Jeff Bezos gets on 60 Minutes and says, it's not Amazon's fault, the internet happened. Well, of course, he's right about that. And meanwhile, the traditional publishers are paying the author of a $142 book the same dollar amount that you would get if you were selling a $9.99 book, right? It's the same $7. So if you think about it, which does the greater societal good? The person who writes $9.99 books and gets the $7, or the person who writes $142 books and gets the $7? Right? It's the same $7. So why bother writing books that no one can afford, or that essentially are soaking students who can least afford it? So I look at it and I say the only people who buy a $142 textbook are the people who are required to by their professors, and that's it. And that's a really bad business model. So I'm sort of interested in how this has changed society, and it's all based on things like web technologies, relational database management systems, little business logic, some what they call servlets or whatever it is they're using to provide dynamic HTML, and then all of a sudden you've got a business. And it's not just a business that makes a little money, it's a business that topples industries. And so this is an exciting time to do network programming, I think. And so, it's the kind of programming that really makes a difference. Let's see now. What else do we have here? This is security. Security, secure copy. Security is such an interesting area. There are so many corner points and so many problems that occur with security. What I do, me personally, is I like to be able to deploy my Java programs so that they can play outside of the sandbox. Anybody here know about the sandbox? Ever hear of the sandbox? Applets play in the sandbox? Yeah, well, you know what a sandbox? You're close. You're close. Anyone else? Sandbox? Well, let me say that this. An applet, you know what an applet is? Anybody here want to tell me what an applet is? Java programmers here, right? You've had Java courses. They tell you about these things. An applet, you've heard of this. Has anybody not heard of an applet? No? You never heard of an applet? An applet is a class called the applet class, which subclasses a panel. And what it does is it runs inside of the frame of a browser. And what you do as a web programmer is you write some HTML which has a tag called the applet tag. And what it does is it makes reference to the class that is the applet class. And when you go to visit the web page, it runs the program on demand. Think about that as a security issue. If you ran programs on demand just by visiting web pages, would you want to do that? I mean, normally if you went to shareware.com and found exe files and started downloading them and running them with wild abandon, you'd be infected in 2 seconds flat, right? But if you start to run applets, automatically, just by virtue of visiting the web page, what kind of heck could they wrought, right? I mean, suppose an applet just ran. It could go into your hard drive, it could delete all your files, right? Yes? Well, JavaScript is not the same thing as Java, as you know. A different language, but if you think about it, JavaScript is a whole other question. And put it aside for a moment, just like Flash. It's different language, different environment. With Java running as an applet, what if it could send an email? And you just ran it on demand. You could start spamming people. Or even worse, you could send death threats to the president. That's like a felony, right? And then pretty soon there's like a knock on the door. Hello? Hello? Secret Service. Oh, Secret Service. Oh, how interesting. What can I do for you? I understand you don't like the president. What? Oh, I think he was very fine. I don't have a problem with him. Well, why are you sending him these death threats? I never did. Well, it came from your IP address. We tracked it to you. I just go to a web page and it sends the death threats. I don't have a problem with the president. So there are these issues, right? We don't want to necessarily run programs on demand that could do harm, right? So what do? We create a security manager inside of the Java virtual machine, which is said to be what they call immutable. Once it's created, you can't destroy it. And it gives you a sandbox, which essentially is security with limitations. So when you go to the website and you start to run this applet, all of a sudden there are certain things you can't do because it's a untrusted program. Right? So when you want to... Yes, sir?
I'm sorry, as a user, could you give it access to for example, send out emails or do other things?
Oh, yes, absolutely. But you have to make it a trusted program.
Yeah.
This goes to the question of security. How do you know if you should trust a program? That's a big question. You know, when you download a cab file for an installation into your operating system because somebody said it's time for an update, you know, you have to ask yourself a question. Do I trust Microsoft? No. Right? And Microsoft's a big company. Don't do the update. Okay? Because why? Because your computer is important to you and it's mission critical, and when it dies and you can't get work done, you'll get all pissed off and everything. I mean, it's bad. So now all of a sudden you've got these programs and they're coming in. How do you know that the person who wrote them is the person who claims to have written them? Big question, right? That's a security question. So, for example, I run all of my programs so that they are 100% trusted. But in order to do that, I have to not run them as applets. I run them as signed Java Web Start applications. And that's a rather different thing. So when you look at my Web Start applications, you look at a series of applications that are automatically deployed. There's about 160 of them. And here's one which has access to your speaker and can generate audio and is signed. And because I trust myself, I allow myself to run my own code. And so when I run it from within the browser and it launches this Java Web Start application, it goes through the process whereby it verifies the certificate that signed the applet. So now it can have, let's see, because you can run this too, right? You run it and it'll say, do you trust Doug Lyon? And if the answer is no, it won't run. But it'll show that there's no man in the middle doing an attack on the code before it was downloaded. It's a signed Java archive or jar file. So then I can say something like network programming is great. Now the synthesizer is not particularly good.
Network program is great.
But it works, and it works on demand. That's a text to speech thing. I don't know if you did you understand it? Yeah, sort of. Having seen it and then heard it, maybe it's a little easier to understand. So there are a whole bunch of different interesting and wonderful things that you can download and run on demand. So I can even try a couple of here's a little computer art thing I've got going here, just a fun little animation. And let's see if that works. Yep, there we go. Fun, right? Isn't that fun? Very fun. So I can have access to things like the camera, to the microphone, to the file system, to sending out emails, because I'm running as a trusted application. Once you trust my certificate, and you decide to trust all other applications that have been signed with that certificate, then they run without bugging you. So this is a way in which you can run your Java programs as a first-class deployed Java application. And not only that, it runs on any platform. So when I deploy these things, I generally test under the three major platforms, I'll say: Unix, Mac, and Windows. It doesn't necessarily mean it will run on all platforms. It used to. But now I think what they've done is they've practically outlawed Java on the iPhone. And so for me to jailbreak my iPad in order to run Hello World, I have to void my warranty, which I'm perfectly happy to do, but it makes me a pariah at the Genius Bar. I don't feel it's appropriate to call them geniuses, by the way. I think it's a little presumptive. Certain things that you can do, like here it is downloading, it should go through the process whereby it can run, here it is, Java 3D, which actually takes advantage of the built-in OpenGL accelerated hardware. So once you have access to the various hardware contrivances inside of your computer, you can gain reasonably good support. Some people say Java has to be slow. In fact, the CPU is involved here because this is a predator-prey simulation where the little yellow birds are chasing the... these are birds, by the way. I don't know if you can see they're flying. The yellow birds are chasing the orange birds, and the orange birds are flocking. And eventually what happens is the number of predators will remain constant, but the number of prey continues to decline until there's no more prey left. The birds would normally fly away, but they're contained by a virtual cube. And when they hit the virtual wall on the virtual cube, they virtually bounce off it or something. And so that's you can kind of see the number of well, there's still a couple left. 4. There's one in here. They're not going to escape. This particular game always ends the same way. The number of prey 0. I guess that's the steady state. Sort of like having no paper in the printer. So I have a whole bunch of different I'll say Java applications, but many of them represent different courses. So if I teach a course in computer graphics, then I have a whole bunch of Java 3D web start applications. If I teach a course in networking, I got a whole bunch of networking applications. And so these are the kinds of things that you can do once you become skilled in the field of network programming. So that kind of is an interesting idea. In terms of the course, I'd like to run the course with essentially 3 grade components. The first is going to be homework. The second is the midterm. And the third is the final. Everything will count for 1/3. The homework is something I'd like to see people do regularly. Usually when you submit the homework late, it gets assessed a penalty of 10 points per day late. And I'll be using Blackboard for submitting the homeworks and for announcing the homeworks. There's a book. The course book is called, let's see if you can find it, Java for Programmers. And there it is. And I've got a store whereby you can buy it as an EPUB. Check out my new store. And here it is, my new store. And it's using PayPal, but it also has EPUB books so that you can gain access to Java for Programmers. I've got a copy here for your enjoyment. You can pass it around and look at it. I'm kind of running out of books. I've got another 1 or 2 in the office. the book online, the EPUB version, has, I think it's being sold on Amazon for like $9.99, and it'll download for your Kindle or your iPad or whatever it is you use for a reader. It's an EPUB format book, and I recommend it because I'll be using it for the course. I suppose I could just do a quick search on Amazon to see if it's there. I see no reason why it wouldn't be. Let's see, Java for Programmers by Lion. And here's the Kindle version. And that should work with... What do people here have book readers? What kind of reader do you have, Rich?
Use an iPad for Kindles.
Will that work for Kindle?
Yeah, there's a Kindle app.
I guess it does. Yeah, I have an iPad too. I don't actually have a Kindle. So it says, look inside, Kindle edition. And now I can buy it with one click and deliver it to my iPad. I don't want that. But there it is. There's paper versions, and then there's electronic versions, and whichever you prefer. That's fine. And you can even buy this one here. It's used. I think $25 is a reasonable price for a book nowadays. There are a couple of things that I had wanted to do this semester in order to be able to try and give people a nice networking experience, and writing some little web server of your own, running your own data mining system of your own, a couple of projects I have in mind, but I'm also open to suggestions. So if you guys have some suggestions about a network problem you'd like to solve, or a network project that you'd like to do, I'd be very happy to hear it. There are lots of people who have, ideas about businesses and things that are kind of related to that, and I love to talk about that sort of thing. If you guys have the entrepreneurial bug and you wanted to sort of start a business, or there was something that you wanted to kind of like do, I think that would be really fun, and we could try and work on something like that. At one point last semester, last time I taught the course anyway, we were using instant payment notification servers to correspond with PayPal. So when PayPal had a transaction, it would talk to the server using instant payment notification, populate the database with customer info. And that was kind of fun. Everybody seemed to like that. So you were writing sort of a PayPal transaction system on steroids, which I think is, kind of a neat thing. The rest of the lecture for today, now that you've kind of gotten the overview, is kind of going to be an introduction to networking. And that's sort of a slide-oriented thing. So that's what I've got for now in terms of the intro. Are there any questions? All right. So, yes, sir.
Are we working with any relational database systems?
Yeah, I'd like to try and set up a relational database management system and have you guys use SQL through Java to populate it.
Okay.
So we'll do an introduction to JDBC, which is some people would say it stands for Java Database Connectivity, or other people say it stands for nothing at all. Yeah.
Do you have any experience with Amazon's AWS?
I used the Amazon Web Service briefly, but then they started charging me, and they kind of scared me off.
Yeah, if you hit a certain limit, they...
Yeah, I didn't care for this idea that I would be charged to try and experiment and do things for educational purposes. And I really wanted to focus on some of the open source free things that you could do. What I found was that Oracle is a very fine product, but MySQL is, for all intents and purposes in this classroom, just as good. If you're trying to build a database system that is huge, you probably don't want to use MySQL. But if you're trying to build a database system that is of reasonable size, that's probably an okay thing to have. And relational database management systems are not the only database systems, right? If you talk to the people down at Priceline and they're using Mongo or Hadoop or whatever, these things in general have very high performance and are not relational database management systems. So there's more than one way to skin a cat. And in fact, what I'll do is I'll have one of my students come up from Priceline, and she'll give a talk about what they're using there. Yes, sir?
Is that a different architecture?
Totally different. Yeah. So, like, if you want to just do searches for strings, like be a Google engine, you don't want a relational database management system, because that'll just kill your performance, and it's not going to give you the kind of, search results that you want in reasonable time. So if you have like MySQL, which is reasonably fast, and then you say, I just want to search for a string, and there's lots of strings, it's terribly slow. And then if you want to optimize for the searching of strings and build an index, it can use huge amounts of space. So you can trade space for time. And when you administer it, yes, sir?
Is that based off their algorithms that they're using for the big database?
There are different algorithms for doing string search, as you might well imagine. And if you want to be really efficient for searching certain kinds of things, you're going to be creating a different algorithm than when you want to search for other kinds of things. So it really depends on what you want to do. That's my favorite answer. It depends. And it's true. It's not an easy answer. Search algorithms are generally hard. Are there any computer scientists here? Yeah, a couple. Good. So somebody said to me that computer scientists weren't allowed to register for engineering courses. Is that true?
Previously, but now they're open.
Oh, I'm so glad. Yeah, I don't understand why they would do that. I've often wondered why computer scientists would never take a network course, a network programming course. And so you were told you couldn't do it. That's interesting information. I was teaching computer graphics because they weren't offering it, and then I never got a computer scientist to take it. And I was like, what happened? Don't computer scientists want computer graphics? And I thought they should want that. You weren't allowed. Yeah. Wow. Amazing. There are certain things that are going on in industry which are representing a sea change in the way in which we do business. Right? If you think about it, this idea that you can have portable programs with Java virtual machines has essentially allowed us to have programs that can run anywhere without caring about the operating system. That's a real catalyst in terms of a technology that can be deployed. But what Java has done for programming, XML has done for data. So if you think about extensible markup language, you can create a language for just about anything. So if you take the two letters ML, and then you perturb the first letter, so it's AML or BML or CML or DML, ABCD, EML, FML, anything you want, RML, you'll find that language exists. Someone has made an extensible markup language variant with that letter in front of it. So RML might be robot markup language, and AML might be address book markup language, and QML might be questionnaire markup language, and you can put any letter in front of ML. Someone made a markup language for that. And nowadays what people are doing is making variants with X in it, like FIX, which they use over at NASDAQ, which is the financial interchange for XML. And so XML has been used as kind of the lingua franca for creating a mechanism for automatically parsing database information, just data in general, transmitting data from one place to another. So being able to use XML is kind of important in taking data that you might find on the web and then structuring it into an XML document is kind of a nice way to do data processing. And it avoids your having to write your own custom parser, because the XML has been created so that the libraries for parsing are very well understood and very stable and very fast. So this is one of those things where we'll talk a little bit about XML. At one point when I taught this course in the past, I had everybody doing a final with multi-threaded, multimedia, multicasting. The multis, right? All the multis. And so with that, we had the ability to essentially broadcast packets to our little network, and then everybody could receive those packets, and you could have streaming video and streaming audio, and it could all come out through the different, I'll call it, clients. And so with that idea in mind, I should mention that there are two kinds of basic protocols, and we'll discuss both of these in detail. One is called unicast, and the other is called multicast. And with unicast, you have point-to-point transmissions of data, and with multicast, you have one-to-many type transmissions, or broadcasts of data. And so we'll talk a little bit more about that as the course progresses. Any questions? No? All right. So I'd like to kind of get in touch with sort of your backgrounds in programming. Who here has had a data structures course? Couple? 3? 4? Kyle, you're in one now?
Well, I took something abroad.
Oh, you took it abroad. Okay, that's fair. Arodi?
Yeah.
Did you not take data structures? I'm hearing mumbling. Was that a yes?
Yes.
Yes, okay. Just mumble a little louder. So, as we go through the book, I'm going to try and just sort of cover some of the introductory material topics, and I'm just going to run through them real quick and make sure that you don't want me to review them. And if you do want me to review them, then you'll stop me, and I will. I'll be happy to do it. But let me just make sure that you guys all know this stuff. Let's see now. If you've taken data structures, or you took it abroad, you already know about operators, and you know about primitive data types. You probably already know about base number conversions, converting from hexadecimal to decimal, things like that. Control structures, you would know. Reference data types, classes, interfaces, things like that, you know. Let's see now. I'm going through the chapters in this book now, and I'm going through it just because I want to make sure you guys know about these topics. Static, abstract, and final modifiers, these are not new to you. Arrays and vectors. You guys know about that stuff? Vectors? They're containers, right? No?
It's just with vectors, I've never really used them. I don't remember exactly the difference between an array and a vector.
Well, in array, you've probably used before, right? I'll just run through a couple of examples real quick here. So here's what I've done. My book examples are organized by the same chapter number as the book. So if you look at chapter 8 of the book, and you look in here under arrays and vectors, you'll see a series of examples. And so, whoops, what did I do? So I don't know if I should, how much of this stuff I should do, but I'll just say here's can you see this where you're at? That's clear. So you've probably seen this is a two-dimensional array, a 10 by 10 array. Here I'm setting the main diagonal to 1, and here's a little test that essentially does a doubly nested loop, and if x is equal to y, we're on the main diagonal, and we can set the main diagonal to any value we want. So that's clear, right? It might be a little less clear if you wanted to set the secondary diagonal. right? So if the main diagonal is 1, 1, 2, 2, 3, 3, 4, 4, what's the secondary diagonal, right? If it's a 10 by 10 array, it might be something like first row 10th column, and then second row 9th, third row 8th, right? Secondary diagonal goes like this, whereas the main diagonal goes like this, although if you're looking at it this way, it's this way versus that way. So setting the secondary diagonal might be a trickier program for you to write, but you understand the concept, right? You're decreasing, you're increasing the row, and you're decreasing the column to do the secondary diagonal. So that's your how would you call it? That's your, I don't know, canonical array example. That's not too bad, I think. So now then comes the vector. If you have an unknown number of elements, you can just add the element to the vector. And then you can get the size of the vector, and everything that's contained inside the vector is a reference data type. Primary difference between this kind of an array, this array of int, is you have you have allocated the primitive data type array storage so that it's fixed and the array becomes immutable. You cannot make this array get bigger. Whereas with a vector, you're going to make only a series of references. And so the only thing the vector is storing is the reference list. And you can keep adding to the size of the reference list. So let me see if I can get back to...
But it's still an array data type? Is that weird?
Alt-1 gets me back to the project. It seems like an array data type, but it's really not. Let me do a quick look around and see if there's a good vector example, and if there isn't, I'll just write one real quick. So here's a Java class, and I'll call it vector example. Okay, and what we'll do here is PSVM, which is my shortcut for a public static void main method, which I don't like to have to type every time. And now what we'll do is we'll make up a little vector, vector v equals new vector. Okay, and now it wants me to identify the location of the vector class, and it doesn't know where it could be, but it's trying to help me, and it says there's multiple choices. If I hit Alt-Enter, it says, which vector did you want? The Antler Collections vector or Java util vector? I have never used the Antler Collections vector, so I'll just import the Java util vector, and that satisfies the compiler. And now what I'll do is I'll make up a little for loop for integer I equals 0 while I is less than 100, I++. And then what I'd like to do is I'd like to just add some stuff into the vector. So let's just say v.addElement, and I want to add anything I like. I could put in new, let's say java.util.date. So we'll put in the date.
So you're adding an object?
Yeah, I'll add an object, and then I'm adding an instance of a class which you can call an object. Yes. And then what I'll do is I'll say something like this. I'll just leave it alone. So now when I'm done, I should be able to say sout Control J, enter. That'll give me my print line, and then I can say size of the array is size of the vector is equal to v.size. And so presumably there'll be like 100 elements in there, and if I want to grab one of those elements, I can say something like this. Yeah, call it an object if you like. Object O equals v.element at and we'll give it a number. How about 50? So let's see what time it was at that time. And now toString is a part of the primordial object class, where the object class is residing in java.lang. And so what we'll do is we'll say SOUT Control J, enter O, and that should take the date and print it out neatly for us. So my expectation of the output from this program is that it will print the size of 100, and then v.element@at will return an instance of the date, and that as system.out.println will invoke the toString method, which should give us a reasonable printed representation of the date. And if we wanted to have some idea as to what time it was before we ran the program, we might like to print that out as well. So let's just print out new date. And now I have multiple dates. Let's try that. Alt-Enter. I'll get to you in just a second. And there it is. Go ahead.
So it's similar to an array as it's indexed by integers. It's not like a hash where it's indexed by keys.
No, it's just like arrays in that sense. It's indexed just by integers, but it's expandable, and you can put in as many elements as you have resources for. It's allocating this dynamically off the heap. And so now if I run it, there it is. So apparently it takes 0 time to get to the 50th element. Well, maybe I should have put in a delay in there or something. But that's okay. And the time is probably not 0, but making 100 elements doesn't take very long, less than a second. So there's a good vector example. Yeah, let's get through some of this. I'll be taking a break. In the middle of the class, we go from 2 to 4:30. And I'll try and take a 10-minute break. See what else do we need here. Wrapper classes and strings. You guys know about wrapper classes? The difference between int and integer. Right? Integer is the reference data type that corresponds to the primitive data type int. Capital float versus lowercase float, where capital float is the reference data type. It's the wrapper. How about exceptions? You guys have all used exceptions? What are the two kinds of exceptions? Well, that is certainly an exception. There are checked exceptions and unchecked exceptions. Right? What would if I had a checked exception, what would be a good example of a checked exception? How would you create a checked exception? Well, there are computer scientists here. They can tell us. No? This is why they don't let you take engineering courses. Then you'll know how to create your own exceptions. So it turns out if you had to do something like work for a company that wanted to take payments, right? Let's say somebody gives you a number. It's a credit card number. You want to check it with the merchant, and then if it doesn't pan out, deadbeat detector, you throw a credit card exception. Bad credit card, right? But you don't necessarily want to create a graphic user interface because the graphic user interface may be something that gets rendered in JavaScript or in HTML or in Swing or in AWT or in SWT or maybe on a phone. Who knows, right? So you just want to handle the business logic of checking for correct credit cards. And then if the credit card is bad, you throw a credit card exception and let the caller who passed you the credit card for checking get told that this is not a correct credit card. So you deferred how you handle the interface to the human. You defer it to the interface designer who is designing some thing, maybe with JavaScript or with Java server pages, or who knows. So what you do is you subclass the exception class, and you make what's called a checked exception. So with a checked exception, you have to try and catch that exception. You have to surround it with a try-catch block, or you must put it in the throws clause of the invoking method. Right? So if you want to try and do file IO, that's a checked exception. But if you want to try and divide, let's say divide by 0 is bad. Don't divide by 0 because your eyeballs will turn black and fall out. I know this is true because I learned math on the street. So as it turns out, that's a runtime exception. Right? It subclasses the runtime exception class instead of subclassing the exception class. So you don't have to try and catch every division, because that would suck. I mean, who would want to program in a language where you had to put every division inside of a try-catch block? So instead you make it a runtime exception, which is an unchecked exception, versus a subclass of the exception class, which is a checked exception. So checked exceptions always appear in the try-catch block or in the throws clause of the invoker. So let's try an example. Let's see if we got some exception examples in here. All right, so here's someone who's trying to do something with a file. You try and do something with a file input stream. What if the file is not readable? What if the file can't be found? Well, that can throw an exception, file not found exception. What if you want to divide through by 0? Right? Well, maybe that's bad. Don't do that. Don't divide by 0. You can try and catch that exception, and you can just print out, look, don't divide by 0. It's bad. I wonder if that will work. Ooh. And there it says, oh, look, I got not a number, and then I tried to catch the exception. It said, don't divide by 0, and then I got an arithmetic exception, divide by 0. So let's try a throws example. Tell me if I'm going too fast, okay? I mean, I can actually do a lecture on exceptions. Would you like the lecture on exceptions? No? So with the... No, anything but that. So here we have somebody trying to create a new file reader to open up a file, and then instead of trying to catch the file not found exception, instead what you do is you defer the handling of that error to the invoker. And so what you do is you throw the file not found exception and you chain that up. Right? Let's try an example with a runtime exception. We'll make a new class, and we'll call this a runtime exception example. How's that? And in my runtime exception example, what I will do is PSVM Control J enter. Let's try and print out SOUT Control J enter 1 divided by, well, let me do this. Oh, yeah. 1 divided by 0. What does that do? The compiler likes it. But he says you can't divide by 0. Well, he says it's an exception, and it's a runtime exception, so I didn't have to try and catch it. Now suppose I took the code and I surrounded it with a try-catch block. Try-catch. What we'll do here is we'll say SOUT Control J enter. Let's see now. Danger! Dividing by 0. How's that? And we'll hit run, and yeah, I was able to catch the runtime exception. Notice the compiler didn't require that I try and catch it, but I could. So trying to catch runtime exceptions is an optional way for you to approach the error handling inside of your code. You know, you can find all kinds of interesting and wonderful runtime exceptions that can occur in math, like if you were in the trig functions, for example. You might try to take the log of 0 or something or other. there are these things which basically throw not a number, and you're not supposed to do them. I think arctangent of 90 degrees is one of them. So it's just a way to do, I'll say, to do error handling. Exceptions become very important when you do remote method invocation. For distributed computing, which is a basic topic in this network programming class, every single method can throw a remote exception. And that means that the caller gets notified through the network of something bad happening on the remote machine, on the computation server. Let's see what else we got. Packages. That's kind of a big, important topic. You all ever have any experience with packages? Yeah? You've imported things, you've created your own packages. I can tell you that when you look at my my project, you can see a lot of packages. Tons and tons of packages. And as a result, I'm able to organize my code reasonably well. Or at least I think it's reasonably well. For example, if I wanted stuff that was just on math, you were asking about sort of like arrays before. There's a whole bunch of stuff just for doing linear algebra. There's one-dimensional matrices and 2 and 3. It goes on and on in terms of math stuff. So, those kinds of data structures are sort of important. I group them all together in a package. Let's see now. Nested reference data types. That's a big one. And so with nested reference data types, I have inner classes, anonymous inner classes, named inner classes. Are you all familiar with that stuff? No? Not so much? Nested reference data types? I can tell you that with JDK 1.0, nested reference data types did not exist. But JDK 1.0 was obsoleted in 1995. And I remember when they added the nested reference data types, and I remember thinking Java is no longer a small language. Of course, it's gotten much bigger since then. So, as it happens, with nested reference data types, what you have is inner classes, inner interfaces. You basically have classes inside of classes. That's what you get. And what that enables you to do is it enables you to create the classes with wild abandon, and you don't necessarily have to name them. So then your question becomes, okay, if I don't name my classes, how does the linker find them? Because you have to be able to find all of the names in your namespace. The linker has to somehow have a handle on those names, even though you have defined them anonymously. That is, a class with no name still is a reference data type, still can be instanced, and as a result of its being instanced, that reference data type must appear somewhere in the heap so that the linker can invoke it. So then the big question becomes, how does the linker make a reference data type with no name into something that can have a handle to? And so the answer to that is the same answer that they use for C++. Does anybody know how you do that? Nobody. It's called name mangling. So has anyone heard of name mangling? No? Name mangling? If you look at, here, I'll give you an example. I'm going to do this with the command line because I'm a little bit more comfortable with the command line. Let me think about this a second. J for P, out, production, J for P, dir, okay. GUI, run, dir. Yeah. So here's a good one, right? You're looking over here and you see, look at these dollar signs. What are these doing here? What's that about? In fact, if I said dir and piped it into more, I think I can see, like, there's a ton of, here's a directory GUI, and now there's directory GUI $1. What could that be? Here's analog meter, right? And then there's a meter color zone, and a meter $2, and a meter $1. What could that be? Yeah, an anonymous reference data type that resides inside of the integer run slider, and apparently there are perhaps 5 anonymous reference data types which are built in, and the classes all appear separately in the file system, and the linker will find these, and they look anonymous to you in your code, but in fact the linker finds them, and they get dynamically linked at runtime. You got a question?
Yeah, could you show this in text form?
Yeah, sure.
Integer run slider form?
Yeah, I got a bunch. Let's see. GUI run and integer run slider. Let's see. First of all, what does that do? Let's run it just for fun. So here's a little GUI element, and what does this do? Well, I see these sliders and I see this text field. Now if I change the slider, I would expect the text field to change, and it does. So that makes the slider a controller, and it makes the text field the view. But if I go into the text field and I change the text field, let's say 49, enter, it also changes the slider. So the slider now becomes not just a controller, but it becomes a view. So what happens is there's an underlying model, and this is a model view controller paradigm. So as the model changes, it updates all of the things which could view that model, including the text field and the slider. So as a result, you can have a consistent mechanism underlying the graphic user interface. So let's have a look at some of these wonderful things. Here is a runnable graphic user interface element. Is my resolution set so you can see that okay in the back? Yes? Arodi, how you doing there? You're shaking your head. You can see it okay? So essentially what this says is that I've got a run text field, and what it does is it knows how to run itself. That's called the command design pattern. You all know what a design pattern is? No? Yeah, design pattern. I'll give you an example. In engineering, if somebody talks to you about a trestle bridge, we kind of know what a trestle bridge is. It consists of trusses that are supporting a roadway. If they say, well, I want to use a suspension bridge, we kind of know what that is too, because it's got a couple of trusses that support a cable which support the roadway. So there's a basic design pattern that you talk about which helps you to solve a well understood problem when it comes to talking about bridges. So when I say trestle bridge, in your mind you know immediately what kind of bridge I'm talking about. And when I say suspension bridge, you know immediately that's a different kind of bridge. And when I think about like the George Washington Bridge, I think about a completely different kind of bridge than, let's say, the Tappan Zee Bridge, because one is a suspension bridge and the other is a trestle bridge. So when I think about different kinds of ways in which I can design a bridge, I usually identify these designs by name. Well, as it turns out, in any mature field of engineering where you're solving common problems, you want to have names that allow you to catalog the solutions to these problems. Well, design patterns in software engineering are a way in which the emergent maturity of that field allows for the reusability of design. And so when you think about software design patterns, you think about names which allow you to picture standard solutions to problems. And so common patterns like this run text field essentially gives you a graphic user interface widget which knows how to run itself. So when I start to add text fields, I don't have to go to multiple places inside of my code in order to be able to alter their behavior. Consider the standard way for creating a graphic user interface in Java, and you let me just see how I can do the shortcut on this. Alt-1. Okay, I'm going to do that again. Alt-1. Let me show you the wrong way to design a graphic user interface. Stop that. I don't know why it keeps doing that. That is bizarre. I think it's me and my trackpad facility. It's very poor. So what I'll do here is I'll show you a graphic user interface which is used for an image processing program. This is called the filter frame. It's a frame which shows an image and has operations that do image processing operations. And so what it has is a menu and then menu items. Now when somebody performs the action of selecting a menu item, an action performed method is invoked. And now I can say, well, if somebody says turn the image gray, then do the gray thing. If somebody says turn the image blurry, do the blur thing. Otherwise, go to the superclass and you can parse the other menu items in a similar way. And then you have to go and you have to visit the program when you want to add a menu item. You have to add it here to create the menu item so it's global. You have to add it here, the business logic for dispatching the menu item when somebody selects it. Then you have to visit the program over here, the actual business logic implementation for when you want to actually execute the menu item. Right? That's bad for so many reasons because the different parts of the program get further and further away from each other as you add more and more menu items. Plus, you have to remember to do certain things. And if you forget to do those things, then your program will no longer behave properly. It'll still compile, but it won't work. And so that is the wrong way, right, to create an object-oriented program with a graphic user interface. The right way to do it is to have elements which know how to run themselves. So here, if you want to add a text field, right away you can map the action of selecting that text field into a method that runs. And so by having a sequence of runnable items that all map to the run operation, all you need to do then is implement the run method, and then it will proceed to run itself. So what I have done, and I believe it's Alt-1, is I've created a graphic user interface alternative, and you might consider this, I don't know, idiosyncratic or whatever. But here's the alternative. A whole series of run methods that all know how to run themselves. And so if you go through this, you'll see here's a run a find panel, run button, run menu items, run checkboxes, and not only is it written for Swing, but it's written for AWT. So you have to do is change the imports in order to be able to change your program's outward behavior, which is kind of an interesting idea. If you want to imagine all the different listeners that are available in graphic user interfaces, there's over 22 of them, and people have trouble memorizing all of them. But here what I've done is I've mapped everything over to a single runnable interface. So that's kind of an interesting alternative, I say, to what I would call the standard Java approach to design of graphic user interfaces. So here's that model view controller again, changing the touch tone speed in milliseconds. Here's where you can interact with it, adding your calling card, changing whether you have modem dial or speaker dial. These sorts of things can all be done in a I'll say using the command design pattern. Here's a run label that uses equations. And you can see all the equations that you can format for. It's basically just Greek letters with superscripts and subscripts. Let's see if we got another one in here. Is that the one we started on, the run int label slider panel? It's kind of an advanced topic. This one is using annotation, which is a whole other lecture. So I'm not gonna get you guys distracted by that. I think we need to take a break. I think that's kind of what Brian was going for just now. And it's 3:30, so it's certainly time for a break. You know what happens is I get carried away. So if you guys want a break, just say, hey, can we have a break? And the answer is almost always yes. So let's take a 10-minute break, and then we'll get back to it. Thanks.